Hello, this screencast will walk you through how to complete the universal screening graph that we did as a group exercise in class. So go ahead and open up that graph. If you don't have it saved to your device, you can locate it on ReggieNet under week 3, 4. Go ahead and open that up. Once again, this screencast will be how to use this Excel file on a Mac. First, let me walk you through what you have for this file. So, over here, this table is normative data. Now, when we calculate our local norms, that's where we'll be inputting that information. So this is the 90th percentile, 75th, 50th, 25th, and 10th. Just below that normative data table, on the left-hand side, there's a box that says chart title and then a green box. Now the green box you can actually type on. So just for the sake of example, once again, we're going to be dealing with oral reading fluency data. So go ahead and type that in. You can type in Dibble's screening data, and that'll automatically fill down here in our graph. So if you look below the two cells that we just worked on, column B, row 13, cell B13, and cell B14. Cell B13 is labeled vertical axis, and then you can type on the green box. Remember, just like we talked about with the can't versus won't graph, vertical axis is our dependent variable. It's what we're actually measuring. So for the case of oral reading fluency, we're going to be measuring words read correctly. Down here, column B, row 17, or cell B17, it says select student index to print. And then there's a green box just below that, column B, row 18, cell B18, and there's a number. So that number right here corresponds to column G, which is labeled student index number, and there's a very prominent blue arrow pointing from cell B17 up here to cell G1. So when you want to graph an individual student's data in comparison to the universal screening data for that grade, what you'll do is you'll locate their student index number. Student index number's here, and the student's name will be here in column H. So once again, we'll use Doc as our student. So if we want to find Doc's scores to graph, we see his name corresponds to the index number 14. So then you just go over to column B, row 18, and you type in the number 18, press enter, and that will, as you can see, that auto-populates this graph with his data. So right now, this is his fall score, this is his winter score, and this is his spring score on the oral reading fluency passages of Dibble's. But we don't have anything to compare those scores to, so we can't really say if he performed well or if he performed poorly. So I typed in 18. You should type in 14. That's Doc's number 14. Okay. So to make those comparisons, we have to calculate our local norms. Remember, we talk about using local norms because it moves beyond just matching students based on demographics, and it helps to control for issues of acculturation or issues of individual culture or life experiences. So that's what we're going to move into now. So go ahead and scroll down Well, first of all, scroll all the way back up. I'm sorry. You can see here in column I, cell I2 is labeled fall, and all the scores below this represent the beginning of the year or fall universal screening. Column J, row 1, column J, cell J1 is labeled winter, and that represents all the universal screening data from the middle of the year or the winter benchmarking. Column K, row 1, cell K1 is labeled spring, and all the data below that represents the end of the year or the spring universal screening performance data. Now you can go ahead and scroll down to the end of the highlighted columns. So below participant 100, so you can input up to 100 different students in this file, you'll see the labels 90th, 75th, 50th, 25th, and 10th. Directly to the right of those labels, column I is where we're going to calculate our local norms for the fall or beginning of the year benchmarking. So directly to the right of the 90th, which is cell I-103, column I, row 103, directly to the right of the 90th label, double click, and that'll allow you to type in that cell. Now the code for the percentiles, or the formatting of the cell, is pretty much the same. The only thing you'll change, you'll just make a slight difference or a slight change to this formula for the following cells. So make sure you've got your bar is blinking here in cell I-103. Type equal sign. Now you're going to spell the word percentile, P-E-R-C-E-N-T-I-L-E. Parentheses, and it'll come up, it'll show you what the formula for percentile looks like here. And when they mean array, they mean the entire range of the data that you want to calculate the norms from. So for the fall benchmarking, our array, the data spans from cell I2 all the way down to cell I65. I2, I65. So go back down to your formula, and you're going to type capital I, the number 2, then you're going to put a colon, type capital I, 65, then put a comma, period, then the number 9. Now press enter. So that is our 90th percentile, is 117.9 words per minute is our 90th percentile performance. Now we're going to do that again for the 75th, the 50th, the 25th, and the 10th. Everything stays exactly the same except for the number that you put after the period. So double click the cell I-104, double click, equal sign, type the word percentile, parentheses, put your array in, so it's capital I, the number 2, colon, I, the number 65, comma, period, 75, enter. Now for the 50th, double click, enter, percentile, parentheses, our array, which is I2, colon, I65, comma, 0.5. Now that's our 50th percentile. Let's do it again for the 25th. Double click, equal sign, percentile, parentheses, our array, I, 2, semicolon, or colon, my fault, I, 65, comma, 0.25, enter. Now let's do it for the 10th. Double click, equal sign, type the word percentile, parentheses, our array, I, 2, colon, I, 65, comma, 0.1, enter. Okay, so now we've got our 90th percentile, our 75th, our 50th, our 49th, and our 10th. Now the good thing is, once you enter those formulas, you won't have to, in the beginning of the year column, you won't have to do it again for middle of the year or end of the year or winter and spring. So what you'll do is you'll highlight these cells that you input the formulas in, copy them, and then just paste them in the following columns. It'll automatically change the array, and you won't have to input those formulas again. So these are our local norms, and remember, below the 10th percentile represents a significant discrepancy from an individual's peers. So if a student scores 37 or below at the beginning of the year, their performance is significantly lower than what their peers have shown on an identical task. Now we need to take this data and we need to put it into our normative data table up here. Now you can't really copy and paste from where we calculated our norms, because that will copy and paste the formula, not just the numbers. So that'll mess up everything that's connected to the normative data table up there. So what I would do is I would recommend that you write down each of those scores just to make it that much easier for you to type them in. You don't have to constantly toggle back and forth. So that's what I'm doing now. I'm writing down all these scores. 691. And I'm going to go ahead and I'm going to round where applicable. So if you remember our rounding rules, if it's 0.5 or above, then you round up to the next highest number. If it's below 0.5, then you round down. So for instance, 117.9 would round up to 118, 73.5 would round up to 74, 123.2 would round down to 123, 59.5 would round up to 60, 46.4 would round down to 46. Okay, once you've got your scores wrote down, scroll back up to the top of the page and go over to the left side to the normative data table. We're going to populate these cells. We're going to populate all these cells right here. So first we're going to start with the fall column, or C2 through C7. So those are the percentile scores that correspond with our fall column right here. So let's go ahead and type those in. Got 118, 102, 74, 49, and 37. Now let's do that for the winter. Again, that corresponds to the norms in column J. We've got 123, 106, 91, 60, 46. Now we're going to populate the spring column, and that corresponds to column K. So we've got 171, 127, 107, 69, and 50. So go ahead and scroll down And this shows you a preview graph of not only the norms that we calculated, but also the individual students' data as well. These colored boxes are called like box plots, box and whisker graphs. And remember, the top of the line, top of the vertical line, is equal to the 90th percentile. The highest horizontal line is equal to the 75th. The middle horizontal line is equal to the 50th. The lowest horizontal line is equal to the 25th. And the endpoint of the bottom vertical line is equal to the 10th percentile. So you can click and drag this graph to a Word document if you would like. Or what you can do is you can go to the bottom here and click on the Chart tab. And that'll give you a full-size chart for whatever student you select. So what is this graph showing us? Well, at the beginning of the year, we can see that Doc was below the 25th percentile, but higher than the 10th percentile. And remember, anything equal to the 25th percentile or higher is considered the average range. So we want you to be at or above this line. Scores at the tip of the lower vertical line and below represent a significant academic discrepancy. And that's an instance where you may immediately refer to a problem-solving team for individual problem solving. But Doc has fallen right here between the 25th and 10th. So that's something where a teacher may elect to start the process first with a classroom-based intervention approach, or refer for a small group Tier 2 intervention. And we'll talk more about Tier 2, small group, individual problem solving when we move into our discussion of multi-tiered systems of support. But then this is also valuable because it plots Doc's progress across time relative to the group performance of his peers. So you can see he was just above the 10th percentile at the beginning of the year, but the amount of growth that he has shown across time, those three benchmarking periods, has not been adequate, one, to move him out of this significantly discrepant level, or into the average range. So you can see he was significantly discrepant at winter, and also he showed a general lack of growth and ended up being significantly discrepant during the spring as well. Once again, you may have to put this in a Word document for a report for general ed teachers, grade-based problem-solving teams, individual problem-solving teams, your school psychologists or parents, and you can just click and drag this graph to a Word document if need be. That's it. I hope that was easy enough to follow, and as always, if you have questions, feel free to ask.